Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The reagent is sodium ethanethiolate, Na plus SCH to CH3, a strong nucleophile and weak base. The substrate is a secondary alkyl bromide, 1-bromo-1-methylcyclopentane. Actually looking at the structure, the carbon-bearing Br also bears H, CH3, and is part of the cyclopentane ring, making it a secondary carbon. The conditions, strong nucleophile, no bulky base, secondary substrate, favor SN2 reaction. Moving on to the next step. SN2 proceeds with inversion of configuration, Waldane inversion at the electrophilic carbon. Moving on to the next step. In the starting material, at C1 of cyclopentane, CH3 is on a plane, up, bond, H is on a dashed bond, going back, behind the plane, and Br is on a bold wedge, coming forward, in front of the plane. And for the final step, the nucleophile -SCH to CH3 attacks from the back side, opposite to Br. After inversion, the groups that were back come forward and vice versa. So the SCH to CH3 replaces Br but from the opposite face. If Br was on a bold wedge, front, SCH to CH3 will end up on a dashed bond, back, and H which was on a dashed bond, back, will now be on a bold wedge, front. After inversion, C1 has CH3, up, plain bond, unchanged, SCH to CH3, dashed, going back, H, bold wedge, coming forward. This matches option C, which shows CH3 up, plain, SCH to CH3 on dashed bond, back, H on bold wedge, front. A shows retention of configuration, SCH to CH3 on bold wedge like Br was, which would be SN1 or neighboring group participation, not SN2. B and D show an additional methyl group on the adjacent ring carbon that is not present in the starting material, making them incorrect structures. D also shows the same incorrect additional methyl, and the connectivity is the same as C, but with extra methyl. Therefore, the correct answer is C. Therefore, the correct answer is option C.